Hey, hi all. So today we'll be looking at a CKA killer coda scenario related to pod affinity, right? So let's understand using visuals. So we have a Kubernetes cluster, right? And we can have n number of nodes. So we have node 1, we have node 2, and node n. So node n is like n number of nodes we can have in a Kubernetes cluster. So now we have a requirement that we have a new pod 2, and we want it to schedule on a node where pod 1 is already running, right? So in this scenario, we'll be using pod affinity. So what's the requirement? There's some pod 1 which is having some labels, and it is already running on node 1. So now we want pod 2 to run on the node where pod 1 is already running. So we don't know like whether it is running on node 1 or node 2, but the relation is pod 2 should run on the node where pod 1 is already running. So in that case, we'll be using pod affinity. And what is pod anti-affinity? That if we want this pod 2 to run on node where pod 1 is not running, right? So this pod 2 will run on some node like node 3 or maybe node 2, but it will not run on node 1 because pod 1 is already running. So in that case, we'll be using pod anti-affinity. So I guess we are clear with pod affinity and pod anti-affinity. So let's see the definition, right? So see, interpod affinity and anti-affinity allows us to constrain which nodes your pods can be scheduled based on labels of pods already running on that node and not the node labels. So now we are going granular on the pod level and not on the node level. So based on the pods which are already running on that node, we can either use anti-affinity if you want to schedule on some other node, and if you want to schedule on the same node, we can use pod affinity. Then again, we have two types, right? The first type is preferred during scheduling and ignored during execution. And we have required during scheduling and ignored during execution. So what does this mean, right? Preferred in the sense they will try to satisfy the condition. If it is satisfied, it's well and good. If not, it will be ignored. So this is preferred. And if we if we go with required during scheduling and ignored during execution, it is mandatory to satisfy the condition. So in this case, the condition will not be ignored. Then what is, let's understand this phrase, right? Required during scheduling and ignored during execution. So in both the cases, it's ignored during execution. So say some pod which is already running on the node, so it will not be moved out from the node. So this pod is already running. So if it is running, so they are saying ignored during execution. So it will be ignored during execution. But while scheduling, they will try to schedule on the node which will satisfy the condition. And for preferred, if the condition is satisfied, they will schedule. If not, they will ignore and they will schedule on some other node. But if required during scheduling, pod affinity is used. In that case, the condition must satisfy. If not, the pod will be in the pending state, right? It will not be scheduled on some other node. So now let's jump into the scenario. So what we need to do is they have provided a manifest. So let's take backup of this one, right? Because it's very necessary to take backup, because if you mess up with the manifest in the exam, then we will not be able to reproduce it again. So let's take backup. So root, then pod pkp.yml. Right. So we have the backup with us. So we have the backup ready, and now let's start reading the question and modifying the manifest. So let's open the manifest. So see, what they're saying is the pod should be preferred. So this is the most important word. So this will give us a hint that we'll be using the preferred during scheduling and ignored during execution pod affinity, and not the required during scheduling, because of this word preferred. So this is a very important word. So we need to read the question very carefully. And what they're saying, they need to be scheduled on nodes where pods with label level is equal to restricted are running. And they have provided us the topology key as well, right? And they're saying that nodes, no taints on nodes, so no tolerations are required. So that's a good thing, right? So we don't need any kind of taints and toleration in this scenario. So let's open another tab and let's see how many nodes we have in the cluster. So kubectl get nodes. So we have two nodes, control plane and node 1. Now let's check for pod, kubectl get pods, and we need to see on which node they are running, and also we need their labels, right? So show labels. So we are passing two flags. The first one is option o wide, so we'll get the node name where they are running, and show labels will show the labels of the pod. So we see that it is running on node 1, and we have the same labels. Label is equal to restricted as mentioned in the question, right? So this pod restricted is having these labels, level is equal to restricted, and it is running on node 1. So now the new pod which will be scheduling, it should run on node 1 and not on the control plane, right? So now let's modify the manifest. Let's come inside spec and let's go to Kubernetes docs. In interest of time, I've already opened the docs. You can open the docs in the exam, and on the right hand side, you can click on this interpod affinity and anti-affinity. Scroll down to the manifest, and let's start copying. So we'll be using this affinity. Put it under spec. Then this one is pod affinity, right? So we need pod affinity, but this one is required during scheduling, and we need preferred during scheduling. So we'll copy this manifest for pod anti-affinity and we'll modify to pod affinity, because we need the preferred pod affinity and not the required. So let's modify to pod affinity, and let's modify the labels, which key is level, and the values, we have only one value, that is restricted. So make sure that we have no typos. So level and restricted, yeah. So that's good. Let's change the topology key as well. They have provided us the topology key. So let's copy, paste, and I guess that's it. We're done. We have copied the required manifest from docs. We have changed pod affinity, pod anti-affinity to pod affinity, and it's preferred during scheduling, ignored during execution. And also we have changed the labels as key level is equal to restricted. So that's it. So kubectl create -f. Let's create the pod, and then let's check kubectl get pods -o wide. So it should be scheduled on node 1, not on control plane. So that's it. You see that the pod hobby project is scheduled on node 1, where pod 1, whose name was restricted, was already running on node 1. And we can check the labels as well. So let's check the labels. kubectl get pods -o wide show labels. I think there's some issue. We have let's check for history, which command did we run. Okay, we have messed something, I guess. kubectl get pods. Yeah, so nothing. kubectl get pods. kubectl gets pods -o wide show labels. So be mindful of which commands you're running, right? So see, we were having this level is equal to restricted, which was already running on node 01, and using pod affinity, we have scheduled a new pod having labels level is equal to hobby, schedule on node 1. So just an heads up, I appeared for CKS, and I solved 10 questions, and on the 11th question, what I did is I messed up on the candidate node. So in exam we have 3 nodes, right? So we have a candidate node which is outside the cluster, and what I did is I modified the kube config. I was trying to modify the kube config file, and I messed up with certificates, and then I was not able to, because I did not take a backup, because there was time pressure. So I messed up the kube config, and then the I was not able to solve the next 6 questions. So that's the reason, be mindful of which commands you're running, and always take a backup of important manifest which you are modifying. So in case there's some issue, we can anyways retrieve the file at any point in time. So that's necessary, and be mindful of which commands you're running. So I guess we have achieved the scenario. We can validate. Yeah, just let me remove my name from here. So it says that the validation is successful. So just to reiterate, you have a Kubernetes cluster and you have multiple nodes on the cluster. And then you have a use case wherein you have some pod which is running on some node. So we will not hard code this node 1 and pod 1. So some pod which is running on some node, and now we have a new pod and we want the new pod to schedule on the same node where the earlier pod is running. So we'll be using pod affinity. And if you don't want the new pod to schedule on the node where the old pod is running, in that case we'll be using pod anti-affinity. And if you want to force, in that case we'll be using required during scheduling, ignore during execution. And if we want it to be preferable, in that case we'll be using prefer during scheduling and ignore during execution. So if the condition is not satisfied, it will ignore and it will not keep the pod in the pending state. So that's it. Thank you for watching.